Hello and welcome. We're going to be looking at some more wave relationships. This goes along with my first part that I did where I talked about frequencies and wavelengths. In this episode, I'm going to be talking about the energy that these waves have. So the frequency and the energy, I said, are directly related to each other. So as the frequency increases, so will the energy. And as the frequency decreases, so will the energy. You can see we have a formula here that's been used to calculate this. It has another constant in it, h. H is Planck's constant. Now, for this particular equation that we have, energy is going to have a unit of joules, and that is a typical unit of energy. And you can see that this Planck's constant, very, very small, isn't it? 6 times 10 to the minus 34th joules, and that's a very small number. But then again, we're talking about light. So light does have some energy, but it doesn't have huge amounts of energy. So that's why the number here is so small. So let's take a look at how we use this in an energy equation. So here's my first one. It says violet light has a frequency of, and it gives a number there, in hertz. Remember, the frequencies are measured in hertz. And it says, what is its energy? So I'm going to use the formula that I've been given for this right here. Energy is equal to Planck's constant times the frequency. And just like last time, I would really recommend that you just write out the formula and then plug the things in and solve for a variable. Now in this case, it's saying, what is the energy? So I'm going to be solving for E in this particular equation. And it says that violet light has a frequency of, and it gives us this big number over here. So I know that the frequency is 7.230 times 10 to the 14th hertz. And H is a constant. It always stays the same. And it is the 6.626 times 10 to the minus 34th number. Not a lot of algebra with this one here. Don't have to use our fraction button. We can just multiply these two values together. Use your scientific notation key on it. And when I do that, I get a value of 4.791 times 10 to the minus 19th. And that would be in joules, because it's an energy. Again, it's a really small value because we're talking about light here. So light doesn't have a lot of energy associated with it. All right, then. Here's one down here. Let's see how this one is different. It's pretty close to the same thing. So I'll tell you what. I'll give you a minute. You go ahead and set up your equation. And then let's compare notes. Okay, did you get it? Here's my value. I got 2.89 times 10 to the minus 13th joules. So if you set that up, you should have that answer in your calculator as well. If you didn't set it up correctly, you might want to go back and see how that was set up in the previous problem. Well, now we've shown you how to use the speed of light formula to go between wavelength and frequency. And I've shown you how to use the energy formula to go between frequency and energy. What if we had a problem that was going between wavelength and energy? You see, my formula doesn't have a wavelength here. It has energy and frequency. So I'm going to kind of take a little different path here. I'm going to first start with the speed of light formula, and I'm going to take my wavelength and I'm going to change it into a frequency. Then I can take that frequency, put it into my energy formula, and solve for energy. That's what I'm going to have to do. So I got two problems in one whenever I start out with a wavelength, or am I looking at the relationship between wavelength and energy. So let's do that. Two steps. The first one is I'm going to take my speed of light formula and I have a wavelength here of 4.9 times 10 to the minus 7th meters. So that's what I'm going to put here. And I know that that's equal to the speed of light, which is a constant. And now I'm going to solve for my frequency. So again, doing our algebra to this. On both sides. Those are going to cancel out, and I'll be left with my frequency of 6.12 times 10 to the 14th. And this is a frequency, so it would be in hertz. Am I done? Nope. See, I'm only right here in my roadmap. I had wavelength. I change it to frequency. Now I'm going to take that frequency and change it to energy. So, equation number 2. Now this time I have the frequency and I have Planck's constant, so I should just be able to solve for my energy. And the answer that I get is 4.06 times 10 to the minus 19th joules. There. Two-step problem. So now I have another one to take a look at here. Got a microwave. It's going to produce a wave with, tells me how much energy it has. 2.2 times 10 to the minus 23rd joules of energy. And it wants to know what is the wavelength. So this time, look, I've been given the energy, and I want to know what is the wavelength. So let's map out our course here. I need to take my energy, solve for frequency, then I can take this frequency put it into this formula, and solve for my wavelength. I'll give you a couple moments to do this, and then we'll compare answers. Uh-oh, our time's up. So I'm wondering how you did. The answer that I got with two significant digits is 0.0090. And that would be meters because this is a wavelength. Now, if you had some trouble with this, my prediction would be that your trouble is going to be in the first step. Because you see, this time, I'm starting with the energy formula. And in the past, all the other problems, we've taken the frequency and found the energy by just multiplying them together. But this time, I'm starting with the energy, and I'm trying to find the frequency. So we have to do a little extra algebra here. So the energy I can plug in is 2.2 times 10 to the minus 23rd. And Planck's constant stays constant. And I'm solving for my frequency. If I take this, do my algebra to it, those will cancel out. I can solve for V now. And again, I probably should use that N over D button. And when I did that, I ended up getting a frequency of 3.32 times 10 to the 10th. That would be hertz. And that was equal to my frequency. Now I can just take that frequency, put it into my speed of light formula, and solve for my wavelength. Okay, well, I hope that helps.